Welcome to CS3308 Information Retrieval. This is the Unit 7 lecture part 1. And this lecture we're going to cover the concept of web crawling. Now, to review just a little bit, throughout this course we've been talking about the concept of information retrieval. And we started off by looking at how indexes are built and how we use those indexes as part of a search engine or as part of a comprehensive information retrieval capability. We also looked at things such as how we're going to do and collect metrics on it and how we use those metrics to compute or to determine relevance by looking at what the similarity is between the words within a document and the words that we have within a query. We've also kind of gone through and looked at how do I build a search engine around that? How do I actually go back in and query against the index that I've built? Now, what we're doing in this particular unit is we're taking some of those concepts and we're extending them a little bit forward. Now, we've used Google as an example before of a information retrieval solution. So we've kind of said Google, and Google search is an example of information retrieval. And essentially what we're doing with Google is that instead of going out and looking at a corpus of documents such as what we've been doing up to this point using a subset of the Reuters corpus, etc., what we're going to do is we're going to use the pages in the web as our documents. And so the way that we're going to get access to those web pages is through a process known as web crawling. And what we want to do in this lecture is just give you a kind of a high-level overview of what web crawling is, what it entails, and how it works. So basic concept of a web crawler is that we begin with some kind of a seed URL. So for example, maybe our seed URL would be something such as google.com. So we also call this a top-level domain, right? So I have a high-level domain, I have a domain name, actually the top-level domain would be the .com portion, and essentially I can start out that with a seed. Now, the reason we call it a seed is that the first thing that we're going to do is that I'm going to go to this google.com and it's going to return some kind of a page. Inside of that page is likely to be a bunch of URLs. So essentially what I want to do is I want to go get the page, fetch it, and parse it. And when we parse it, we're going to do a couple of things. First of all, we're going to take out and we're going to find all the URLs or the uniform resource locator or the thing that we recognize as being a address for a website. And we're going to parse those all out. And once we've parsed them out, we're going to go put them out into what we're calling a queue. And we're going to talk about this in a little bit in just a few minutes, but that queue represents what we're going to call the frontier. Now, after we've gotten all of the URLs out of that page, we're going to get rid of all the formatting. So we're going to take out all of the formatting, and what essentially is going to be left is just the words. And at that point in time, it's going to look pretty much like the documents that we've been working with in the Reuters corpus. So essentially, I get the URLs, find them all, put them out on the queue, okay? Remove all the formatting, and then after that I can look at it as a bag of words, so to speak, and I can go through and do the computations to determine relevant or to calculate my TF and my IDF parameters, and from that I can actually calculate and compute my cosine similarity. So essentially that's the basic operation of a web crawler. If we kind of look at it from a picture perspective, I'm going to have some set of seed pages. Now, in the assignment for this course, we're going to use one seed page. We're going to use one domain. Maybe we're going to use uopeople.org, right? The problem you're going to run into with this is that as you seed it, it's going to go through it, it's going to look for every link within that page, every URL within the page, and it's going to place it on our queue. And what's going to happen is that's going to build very quickly. And so essentially I can start with one page and I have all these links that go out to other pages, if you can kind of visualize it, each of them pointing to a page, right? And what happens is that each of these pages have links in it, which point to other pages, which have links, which point to other pages, and you get the sense for why we call it web crawling. It kind of forms a web that goes out from every direction, and every page has additional links that go out, and so it builds very, very quickly. So if I were to look at the entire web that exists out there, all of the global internet, intranet, etc. Within it, I might start with a series of web pages, and I'm going to discover things as I go through it. It's kind of this whole linking process where I'm going to go from one page, the links to it, to another page, to the links in it, etc. And all of those pages that I am discovering, I'm going to refer to it as the URL frontier. And of that, it's going to capture some portion of the web. There will probably be some portion of the web that is not seen, that I don't know about, that just simply wasn't captured in the seed pages. And what I can do is, if I really want to find those things, I can continuously add to what's in my seed pages in terms of what I'm going to crawl. So that's the basic operation of a web crawler. Now let's talk about a few complications that come into play. So web crawling isn't all that feasible if I'm talking about doing it with one machine. And you can get a sense for why. Just think about this. I started off with one top level domain as a seed, and every link in it points to another page, and that page points to other pages, etc. And as you can well imagine, it very quickly becomes exponentially large. So doing this with a single machine is simply not going to work. Mostly what I have to do, and obviously we're not going to have the resources to do it within the assignment that we have, which is one of the reasons why one of the parameters of the assignment that we have in this unit is to cap the size of the queue to 500 pages maximum, because it quickly can grow to thousands and millions and potentially hundreds of millions or even billions of pages. So simply not feasible to do it with a single machine, which is one of the reasons why we have to quickly get to a point where we can do this in a distributed processing format. Distributed meaning that I can spread that workload of doing the web crawling across perhaps dozens, hundreds, or in the case of many of the large search providers such as Google, it might be thousands and thousands of different systems. Okay, another complication we run into is there's a lot of malicious pages, pages that are designed to look like other pages, or they're spam pages, or they put words in there because they know that they're going to appear high within a search query, but they really don't lead to any relevant information. So trying to discover what is malicious pages and eliminate them from our web crawling is one of the complications. We even have some non-malicious pages, but ones that really, there's not a lot of information in there, so I really don't want to spend a lot of time digging into and crawling these sites. And what happens in some cases, you have pages that point to pages which point back to pages, and you can kind of get into a bit of a loop. So there's some challenges there. And then there's this concept of politeness, right? And you think about it, what we're doing with our web crawlers, we're trying to go index a page so that people can find it, but the people that produce these pages, the webmasters that have put these things together and are running these websites, they're looking to get and use the bandwidth that they're paying for actual users, people that are coming to their website to look for information, to buy things, whatever the case might be. So we have to make sure that we're balancing our need to get access to them and provide a service to the webmaster, as opposed to becoming a little bit overwhelming to them, such that all of their bandwidth is being consumed by web crawlers such as ours that we're producing. So what does any web crawler have to do? What does you must be do? So some musts that we have is to be polite. And again, it's this whole thing about trying to respect what the owners of those websites are doing, and make sure that we're following appropriate guidelines in terms of how often we're accessing or how much information we're accessing, and the fact that we're only going to crawl those pages that are really appropriate. One tool that we have with this is this concept of the robots.txt, and we'll talk a little bit about this more short in just a bit. But basically what it is, it's a way of webmasters defining what they want robots or a web crawler such as the one that we're developing to have access to and what not to have access to. They kind of set some boundaries over what we can do in terms of indexing their website. And then another element of this is to really be robust. So we want to capture the information on a website such that an individual looking for something relevant there is going to be able to find it. But we want to do so in such a way that we're not spending a lot of time getting caught in a trap. One of those traps such as, pages that point to pages which point back to pages, which can just dramatically expand our URL frontier, but not really get us any access to any more relevant information. So what things should a web crawler do? So the previous one were things that it has to do. We really need to always do those things. But what should they be able to do? And the first one is really kind of this idea of distributed operations. A web crawler that does not have the capability to be distributed across multiple machines isn't going to be all that valuable because of the fact that the web has become so large that in order to really get access to and scale to the point where we can really index either the entire internet or even the intranet of many organizations, I need to have some ability to distribute that workload. In that same vein, it really needs to be scalable. So I need to have the ability to crawl more, access more, index more pages, more sites, etc. By adding additional resources to it. And again, I need to make sure that I'm getting as much performance and efficiency as I possibly can, such that I can make the best use of the available processing and network resources. And by the way, network's a big important one, right? Because think about what you're doing. What the web crawler is doing is it's going out and reading web pages, all of the web pages. So it has to be pretty efficient, and I have to make sure that I'm using the network resources effectively because I need to move a lot of data. Keep in mind that every time I go read one of these pages, I'm basically reading the page. I'm reading the whole page in. I'm looking at all the words. I'm getting rid of the formatting. I'm doing that whole process. So I'm going to consume a lot of network resources, and I need to be mindful of that. Some additional things that the web crawler should be doing is we should be trying to fetch the pages that have higher quality first. In other words, our whole objective is to capture information, to provide an ability for people to go out and enter search terms and come back with relevant information or relevant pages that contain information. So, some pages that have very little on them that just aren't that relative, we don't want to be spending a lot of time doing these. We really want to go after the ones that are going to have meaty information on them. The ones that are likely to come back in our search query as being relevant when I start looking at doing the relevance calculations. Another thing that they probably should do is to be able to support continuous operation. Now, in this class and the assignment they're going to be doing in this unit, we're going to write a web crawler that will basically go through in a single pass and index what we tell it to do. But in the real world, most web crawlers really need to be able to continuously operate. So we have to have a way of looking at the frontier, aging the pages in the frontier so that I'm not revisiting those pages over and over again, but doing so in such a way where I can kind of determine that I'm going to revisit the page if and only if something has changed and only after a certain amount of time has elapsed. And of course, they really should be extensible, and by extensible we mean they need to have the ability to adapt to different data formats. So in what we've done in this particular assignment in this class is that we're going to be focusing on pages that have HTML content, but we know that there are other kinds of content that we're going to find on the web page. Maybe it's Word documents or PDF documents, or perhaps it's Excel spreadsheets. There's a wide plethora of different formats that are out there, and we want to be able to index the information in those as well. So although we're going to focus in this particular assignment in this unit on just HTML content, keep in mind that in most professional, sophisticated information retrieval systems, I've got to have the ability to go out and look at a whole bunch of different formats, such that I can capture the information no matter where it's at. So kind of an updated picture, what it looks like, and we've talked a little bit about this. We go to the seed pages, we get our URLs, and every time I find one of these URLs, I'm putting it into a queue. And let's call that queue the URL frontier. So basically it represents everything that we know about that's out there in the web. And maybe the web in this context is the intranet of a large company. Maybe it's the internet, which is a global entity. But whatever it is, it's a long list of items that we would search through. So dealing with the issue of politeness, there are two forms of politeness that we have to deal with. One of them we're going to refer to as explicit politeness. Now, explicit politeness is that where the webmaster of a particular website has put out a specific file. This is the robot.txt that we mentioned briefly before, and that file tells us exactly what we should or should not do in terms of crawling and indexing that particular website. So it is explicitly telling us how we should deal with that particular site. That's explicit politeness. The other form of this, which is we're calling implicit politeness, and the idea here is kind of a, we need to be reasonable and think about ensuring that we're not doing something that would be that a webmaster would be upset by, even if they haven't specified exactly what we should do. So we need to be polite. We need to kind of keep in mind that the objective of the webmaster is to provide information to users, not us. We provide a service to them. We would index their material, and presumably that would allow people, their users, to find their material. But we have to make sure that we're maintaining a balance, a trade-off between the service that we're providing and the resources that we're going to consume to do it. Now, we're going to consume a lot of resources, and keep in mind that as you go through and you're indexing all of the pages in somebody's website, you're reading them all. So we're going to consume a lot of bandwidth in doing that. So what we want to do is try to make sure that we're conscious of that and that we're going to minimize the amount of impact that we're going to have. So looking at the robots.txt file, so essentially what it is, it's a file that I can go out and put into a particular directory of web pages, and essentially what this file does, it has a protocol that tells us what we can and cannot index, and perhaps even how frequently we should or should not index it. So basically I can use this file as a webmaster to say, this is what I want you to index or not to index, and how frequently or how much detail I want you to be able to access. Or as a developer of a web crawler, I should be able to read that file and adhere to it in order to remain polite. So I really shouldn't be going beyond the bounds of what is specified in this particular file. Now, if you go out, there's a website that actually has all of the information about the robot.txt file format. You can look it up on the internet. So, kind of getting back to and revisiting the whole process of web crawling as kind of a review. The way that it works is that, and again, initially what I'm going to do is I'm going to start off with and I'm going to just jump all the way back here briefly with a seed page. What I'm going to do in that seed page is I'm going to discover all the URLs in it. I'm going to, let me see if I can find that. I'm going to add all those URLs as a queue. Right, so every time I find one, I'm going to stick it on this queue, and that queue, or the sum of all of those pages that are queued up, represents the URL frontier. So obviously, the first page that I get access to, I'm going to process, but then I'm going to go to the next page that it's in the queue and process that one, and then the next page after that. And oftentimes the way it's going to work is once I've processed the page, I'm going to go stick it back at the bottom of the queue, perhaps with some information about date and time and whatnot, so that I know when I should be going back and revisiting that page again. And let's just kind of jump up here. So basically we're going to pick a URL from the frontier. So I'm going to grab one out of the queue. I'm going to fetch the document that URL specifies to. I'm going to parse it. Remember, we talked a little bit about the fact that in parsing it, what I'm doing is I'm going to extract all the URLs. Then I'm going to get rid of all the formatting. And finally, I'm going to take all of the words, the bag of words that remains, and process them as though they were a document. Okay. So once I've parsed that URL, so I'm going to go and check and see if that URL is something that I've already processed. Keep in mind, it's common for a page to point to other pages, right? So the likelihood is that I'm going to have many occurrences in my URL frontier pointing to the exact same URL is pretty high. So I have to have a way in my web crawler to keep track of what I've visited and when I've visited. And so one of the things I want to do before I actually run off and process is I want to double check to see if I've actually gone to this page and processed this content recently. If I haven't, I want to process it, add the data to the index. If I have, then I just want to, perhaps update the time that I've visited this and move along to the next one. So if we were to kind of look at the basic architecture that I might have for a web crawler, I have a number of elements in here, and we'll talk about this one a little bit. One of them is being DNS. And I just want to make a real quick point here. A lot of what we want to be able to do with our web crawler is really make sure that we're very efficient from a performance perspective. And there's a number of areas where we're going to have to look at being efficient. One of them is DNS, and DNS stands for Domain Name Service, and it's essentially a way of looking up the address of a website. So if I had an address such as google.com, right, that google.com is going to be pointed to, or that points to, or it's equivalent of an internet address, which might be something like 19.172.10.5, right, for IPv4. So essentially DNS says I'm going to go look up google.com, and it's going to return me the address that I need to get to. Now, here's the problem with this. DNS is an internet service, so I have to go make a request out to the DNS, and I get a response back from the DNS, and that can take some time. So I have a latency issue here. When I have a web crawler that I'm trying to make very efficient and move very, very quickly because I've got to index a lot of pages, this becomes a little bit of a problem. So we have to make sure that we're using DNS efficiently. The fetch piece of this, again, another thing that has to be very, very important, because when I start fetching it, that means I'm reading the document. That means I'm transferring that particular document over the internet. And when I have limited bandwidth, and I always have limited bandwidth, this is something that I have to be conscious of. So fetching, which basically means just go get the page. The next element that I have in this is the parsing, and basically, as we've already talked about, parsing is about separating the stuff that's in there. So the first thing I want to do is I want to parse out the URLs, right? So any of the links in there that represent a URL in that document, I want to parse them things out, and those are things that I'm going to go put back into the Frontier. I am also going to probably parse out all the HTML or other formatting. So when I have formatting of the document, I don't want to index the formatting. What I want to do is index the content. So I would look at the HTML and all these other kinds of information and get rid of them. I don't really want that. And then finally, I would parse out all the words or the content that's within the document. After this, then I have to start go out and say, have I already seen this? Is this one that I've already processed? Perhaps even represented by a different URL. Maybe I have a different URL pointing to it, but it's the same content. So I need to be able to determine that. And I need to be able to keep track of it. Okay, so I'm going to want to be able to keep track of it, or keep a database of the content that I've actually seen. The next thing I want to do is kind of look at the filtering. So can I go after this one? Should I be exploring it any further? Because is that robots.txt file that we talked about, is it specifying that I need to be limiting what I'm looking at in terms of URL? So I want to determine if the URL that I have that I've identified actually is one that matches something that I can politely get access to. And then the third thing that I need to be really conscious about doing within my architecture is looking for duplicate content, right? So I want to eliminate any of the duplicate URLs that might have out there. So this is really kind of saying, did I have a duplicate document? This one basically says, is there a duplicate URL? Now, why am I looking for duplicate URLs? Well, remember, keep in mind, one of the things we said is what we're going to do is we're going to find the URLs, and we're going to go put it back on the Frontier. Now, if it's a duplicate one, I don't want to put it on the Frontier because I don't want to be searching or going and looking for the status of that particular URL over and over and over again just because I have it out there duplicate number of times. So I want to keep a URL set, a database that lets me know the one copy the one instance of that I want to have, and when I have a duplicate one, I'm just not going to add it back into the URL frontier. So after all of these things, I've parsed the URLs out, and I kind of go through a variety of these filters. I'm going to index it, right, if I match all of these filters, and then what I'm going to do is I'm going to actually take the URLs that I'm finding if they pass through these filters, as long as it's a valid one to get, because I'm not violating a rule specified by the robots.txt. If it's not a duplicate one, etc., then I'm going to add that URL extracted from a document right back onto the URL frontier, and that's going to feed getting additional pages. And again, we talked a little bit about the fact that this is how it grows exponentially, because I'm taking all those links that are coming out of a page, which might point to other pages which have links, which point to other pages which have links, and so on and so forth. Just a little bit about the DNS, or the domain name service. So we talked a little bit about the fact that it has to be efficient, because we're looking it up every single time we go to a URL. I have to look up the name of it to get the actual address. And the problem with this is that again, there can be latency. It has to send a message out and get a message back. All of that takes time, and so we want to look for a solution. One of them is to use local caching. So a lot of computers would potentially cache them locally, and basically all that means is it says if I've looked up Google.com and Google.com returned me an IP address, and let's just say, for example, it was 10.8.5.8, right? I do not believe this is the correct address, but let's just say for an example that it is. Essentially, that entry is going to be put into the cache. So I'm going to say Google.com is the same as 10.8.5.8. and 10.8.5.8 is the same as Google.com. And I keep that on my local computer cached. And so when I see this the next time, I don't have to go out to the external DNS service, ask it what the name is to resolve it. I have it locally. It's cached. So that's one good way of doing it. Another thing that you can do is you can do some batch DNS resolution. So in other words, I'm going through lots of pages, and instead of just sending out one request and waiting for it to come back, maybe I send out 5 or 10 or 20. And I get and that way I reduce the amount of latency that I have from, having to have that latency or sending it out and waiting for it to come back for every single name that I need to resolve, to perhaps 1 out of every 5 names, or 1 out of every 10 names, etc. And then finally, the last point I wanted to talk about just briefly was this whole concept of distributing the crawler. And we've talked about the fact that we really need to be able to distribute web crawlers, because even when we're doing intranet in an organization as opposed to the internet, these can still be very, very large. And so it's going to take too long. I mean, because the number of URLs that wind up in the URL frontier will become very, very large, because it grows exponentially. So the only way to really accommodate this and to make sure that I can maintain my index, maintain that it's going to be fresh, it's going to have the most up-to-date information in it, is that I'm going to have to run this thing across multiple servers, or have multiple web crawler processes. And when I have multiple processes, they all have to be coordinated, right? So I don't want every single one of them going after and trying to index the same things. I want them out there, making efficient use of their time by indexing different pages. So I really need to come up with the strategies that allow me to partition this data and distribute it across multiple processes and multiple servers potentially. So anyways, hopefully this has kind of given you a good overview of what a web crawler is, how it operates, and some of the issues that exist with it. And this would be helpful as you develop your own web crawler as part of your assignment for this unit.